Hi, good morning to all of you. This is Venkatesh. In this video, we are going to discuss about RLC circuit with AC excitation. So in last video, we know how to calculate the response of RC circuit with AC excitation and RL circuit with AC excitation. How to calculate the response of the RL and RC circuits with AC excitation. So that analysis we already seen in the last video. So presently we are going to discuss RLC circuit. So here the circuit shown in the figure like this RLC, and the source is AC source, that is V of t, that is Vm sin omega t plus theta. So here the switch is there, it can operate under the t equals to 0. At t equals to 0 the switch is going to be closed. That's why what is the operation going on before close the switch and after close the switch, and what is the behavior of inductor, what is the behavior of capacitor. So here, so clearly observe the t equals to 0 minus, this is the before close the switch. So at IL current passing through the inductor is 0 and voltage across the capacitor is 0, and after close the switch, just after close the switch, so current passing through the inductor is 0 and voltage across the capacitor is 0. So apply the KVL of this loop, that is of this circuit. So here Ri plus L di by dt plus 1 by c integral of I dt, that equals to Vm sin omega t plus theta. So here we are getting the two energy storage elements. So that's why we are getting the differential integral differential equation. So that's why for calculation point of view, for analysis for point of view, we can convert this equation into differential form. That's why the integral can minimize it to differential equation. So we are using the differentiation with respect to time on both sides. So that's why we are getting the equation is going to be R di by dt plus L into d square I by dt square plus 1 by c into I, that equals to Vm omega cos omega t plus theta. Sin theta differentiate cheste em vastundi manaki cos theta vastundi. That is the main thing. So here I am writing that d square I by dt square plus R by L di by dt plus 1 by L c equals to I. So here I am taking the d by di equals to d, that's why d square plus R by L d plus 1 by L c into I equals to Vm omega by L cos omega t plus theta. So for the total response of this above second order differential equation is combination of complementary solution plus particular integral solution. So here the complementary solution is nothing but transient part, and the particular integral is nothing but steady state part. So first I can find the complementary function. So for calculation of complementary function, so initially I am calculate the roots. So that roots may be real or may not be real, and real equal or complex roots like that. So that's why first I am finding the roots of the equation of d square plus R by L d plus 1 by Lc. So by using a formula minus b plus or minus b square minus 4ac by 2a, square root of b square minus 4ac by 2a, this is the roots for ax square plus bx plus c equals to 0 equation. So that's why the roots I am taken as, so minus R by L plus or minus square root of R by L or R by L whole square minus 4 into 1 by Lc by 2 into 1. So here alpha comma beta are the roots. So these roots must depends upon the inside the root factors. So that's why here I am taking that if R by 2L whole square greater than 1 by Lc, that means what, this value, this root is going to be positive value and it is a real roots. So that's why the condition is going to be over damped system. So the complementary solution is e power alpha t c1 e power beta t plus c2 e power minus beta t. Suppose if R by 2L whole square is equals to 1 by Lc, then whatever the roots, so it is going to be 0, then minus R by 2L, the alpha only presents. So that's why this is only one root, that's why it's a complementary function is going to be e power alpha t into c1 plus c2 t. And when if R by 2L whole square less than 1 by Lc, that means inside the root we are getting the minus, inside the root we are getting the minus, that means it is going to be a complex form, that is simply a plus bi. a plus bi. So that means what? It's a complex function. So due to the complex function we are writing that, so e power alpha t plus c1 cos beta t plus c2 sin beta t. So this is the complementary solution for a second order differential equations. So this is already in the mathematics. So here, so next one we can go for calculate the next one. You can calculate the particular integral. The second solution is going to be particular integral. So for the calculation of particular integral or steady state response, so again the same thing here. So you can assume the function that is ip equals to a cos omega t plus theta, b sin omega t plus theta. So here second order system, that's why I am taking that di by dt. So then I am getting the result d square ip by dt square, that is again I am getting the another equation. These equations, all values are substituting in the equation 2, that is the main equation. So there I am getting that, so r into a omega sin omega t plus theta, b omega cos omega t plus theta, plus L into minus a omega square cos omega t plus theta minus b omega square sin omega t plus theta plus 1 by c a of cos omega t plus theta plus b sin omega t plus theta is equal to Vm omega cos omega t plus theta. So by comparing that, so here again I am taking the part sin omega t plus theta as a one part and cos omega t plus theta is another part, and compare LHS2 or LHS2 or HS. Then what happened comparing the LHS2 or HS? So again we can calculate the a and b values. So we are getting a simple terms. So here I am getting a one term, that is b omega or minus a omega square L plus a by c equals to Vm omega, and second one is a omega or minus b omega square L plus b by c equals to 0. This is another function. By simplifying that, so here I am calculating the b value a into omega or by L into omega square minus 1 by LC. This value substitute in this equation, in this equation. So then I am getting the a factor. So by analyzing like this, I am putting the b value here. So then by analyzing this, so I am getting the a value. So clearly do that. So its calculation is very important. So you should be go for mathematics. So as it is, you can simply substitute the values. So then I am getting like this. So a and b value. After getting the a and b values, we can substitute the a and b values into our main particular integral ip function, that is ip equals to a cos omega t plus theta plus b sin omega t plus theta. There you get the function here. So Vm omega by L into cos omega t plus theta and another constant value into sin omega t plus theta. So these factors, for our simplification point of view, I am taking as so m sin pi. So let us take m sin pi equals to this value and m cos pi equals to this value. M cos pi equals to that value. So that both are I am taking here, and simply I am writing that ip equals to m sin pi cos omega t plus theta, m cos pi sin omega t plus theta, ip equals to m sin a cos b plus cos a sin b, that is sin a plus b formula. So I am simply simplify that ip equals to m sin omega t plus theta plus pi. So what is m? It is a magnitude value. What is pi? It is a phase angle value. So how to calculate the phase angle? Simply from that, where tan pi equals to m sin pi by cos pi. That means what? M sin pi by cos pi means it is a mm cancel, then sin pi by cos pi, it gives the tan pi value. So that tan phi, so we know the factors already, we initialize the above equations, so that's why that can substitute here, and finally I am getting the tan pi equals to 1 by r omega L minus 1 by omega c, and pi equals to tan of 1 by r into omega L minus 1 by omega c here. So it is, so I am getting this is the phase angle. What is this here? It is a phase angle. And how to calculate the capital M? This is a square root of m sin pi whole square plus m cos pi. That means m square is a common, cos sin square theta plus cos square theta equals to 1. So sine square theta plus cos square theta equals to 1. This is a formula in our trigonometry. So that's why simply you can do this, that is the sine square theta plus cos square theta equals to 1. I am applied here. So then substitute the values of m sin pi whole square plus m cos square pi. So take a m as a common, that is a m square. Sine square theta plus cos square theta is going to be 1, that is the square root of m square equals to m, that is value. So that's why I am substituting the values, and then finally we get substitute these values above initialized values. So then finally we get a single equation like this, and then we can calculate the m, so like here, and then you can and then you can go through this, and finally you can write the equation m. This is the important. So therefore I of t equals to ic plus ip. That means the complementary function, particular integral function. The complementary function, so we have calculated already, that is, so what we had calculated already, so that is simply already we calculated here. So this is ic. If the roots are real, you can choose this function plus m sin theta plus, so, and suppose the complementary function is going to be only single root, so complement e power alpha t ic plus the value. So that is the main intention here. It is the main intention. So here, so another, so this is the RLC circuit solution. Suppose the roots are going to be equal, means I of t equals to, so it is going to be roots real single one. So what is that? IC is going to be what? Simply e power alpha t c1 plus c2t plus what is IP? M. What is IP? M into, so sine omega t plus theta plus pi. So this is, so that means it is a combination of two things. So what is the combination? IC plus IP. If the roots are real, so then you can use this formula. If roots are unequal, so you can use another formula. If roots are complex, you can use another third case. Different cases are there, different formulas we can add it here. And here you can take one simple exercise, simple example, that is the problem. So for analyzing the RC circuit. So a circuit shown below, determine the complete solution. What is the complete solution? So there is a complementary function and particular integral. That is a transient part and steady state part. So for the current, when the switch is closed at t equals to 0, the capacitor, and applied the voltage is V of t equals 50 cos omega t plus pi by 4. That means the input is AC, so that function can compare with Vm cos omega t plus theta. Then Vm equals to 50 volts and omega equals to 100 radians, that is a 2 pi f, and theta equals to pi by 4, that is a 45 degrees, and R equals to 10 ohms and C equals to 1 microfarads. These all are going to be given data. So here clearly observe the V of t equals to cos omega t plus theta or sin omega t plus theta. So what is the function they given? That could be taken here. So then apply the KVL of the given circuit and write the equation and substitute the values. So this is, so write the equation and substitute the values. So here RC is the time constant, that is R is 10, C equals 10 to the power of minus 6, that is 10 to the power of minus 5 seconds. That value is substituted here. Finally you can get the function, that is the like this. This is taken as the equation 1. The total solution, the complete solution is this. This is equation number 2. You can make it as equation number 2. So how to calculate the complementary function? Simply find the root, and that root is going to be real, c into e power minus e power alpha t. So e power alpha t, that is like this. So d equals to 10 to the power of 5 and e power alpha t. And then second one is for IP, the particular solution, you can assume a cos omega t plus theta plus b sin omega t plus theta, and dip by dt equals to minus a omega sin omega t plus theta plus b omega cos omega t plus theta. Di by dt equals to this function, and substitute the all values in equation number 1, and finally you can compare the both factors, that is cos omega t plus theta and LHS or RHS. You can compare the LHS and RHS, compare LHS and RHS. So then you can get the two equations, minus 100a plus 10 to the power of 5b equals to 500, and 100b plus 10 to the power of 5a equals to 0. So then calculate the b equals to, in terms of a, this value substitute in that a equation. So there you get the a value. So after getting the a value, after getting the a value 500 by, so this is 5, 10 to constant values, so that a value substitute in the b, so we get the b value. These values substituting in the ip, you get this value, and I of t equals to c into e power the complete solution, ic plus ip. So then here, but the question is there, you can observe the question. So in the question, what happened when the switch is closed at t equals to 0, when the switch is closed at t equals to 0, so under the t equals to 0 condition, the capacitor can access, that means initial conditions, it does not allow the sudden changes of voltages, it does not allow the, so does not allow the sudden changes of voltage in capacitor. Does not allow the sudden changes of voltages, so that's why it is acts as a short circuit. Capacitor acts as a short circuit. Due to that, capacitor acts as a short circuit, the I of t equals to V by R. That means I of 0 equals to V by R. So that is 50 cos omega t plus pi by 4 by R value is going to be 10. So then simplify that, 5 cos omega t plus pi by 4. So here t equals to 0, this factor is going to be 0. Then we get pi by 4 value. That is I of 0 equals to 5 cos pi by 4 plus c into e power t equals to 0. So then e power 0 is going to be 1 plus 5 into e power, like this. So by simplifying this, calculate the c value. So that is 3.535 constant. So finally you can get, substitute this equation into our total response, the total response equation. So this is the total response equation. So in this equation, so then total response is like this, that is I of t, that is a complete solution amperes. This is the example for you, one example. Similarly, you can do that number of exercises. So in RL, RC and Vagaira, so RL, RC, like that. So there also same analysis what we are doing in the theoretical, that can applied in the practical. That is enough. Thank you so much.